Okay, it's a wonderful day. It's a rainy day. I would encourage you before you go anywhere, carry your umbrella so that you don't get to be stranded. Otherwise, welcome to another mathematics lesson video. And today we are going to look at how to find the nth term of a geometric progression. So yesterday's video we looked at how to find the common ratio. Today let's look at how to find the nth term of a geometric progression. Let's begin. Okay, so how to find the nth term of a geometric progression? Now, the nth term of a geometric progression, remember, GP simply stands for geometric progression. So in most of my questions, instead of writing the whole thing of geometric progression, I'll abbreviate it to GP so you should be able to understand what I'm talking about. Okay, so the nth term of a GP, geometric progression, is given by Tn, which this T and small letter n simply stand for the nth term, okay, is equal to A, which is the first term, R, which is the common ratio, to the power n minus 1. So what does this simply stand for? We are simply saying that A is the first term, R is the common ratio, n is the position of the term in the sequence. So let's say they tell you that find the 80th term. So the n becomes the 80th term. Okay, let's look at the example. So I would advise you to make sure that this concept, this formula, you pay a particular attention, know it by heart, because these are questions that never miss in paper 2. And you are required to have a calculator. I just begin my calculator. You are required to have a calculator in this kind of questions, because there are questions that they are easy, you can work out without a calculator, but sometimes they are so complicated that you need the help of a calculator to work with speed, because remember it's 100 marks and it's only 2 hours 30 minutes. So without the calculator, obviously you will not finish all the questions, because there are some of the questions that require a lot of working. So now let's look at this one. Example. Given a geometric progression 4, 2, 1, you can see this is a geometric sequence, okay, which of course continues going. Find the 80th term expression for the nth term of the GP. So the expression is the same as we did with finding the formula in arithmetic progression. Remember that formula we are finding? So for the sequence, that's the same here. We are finding the formula for this sequence as well. So let's begin and see how these things are worked upon. So solutions. Let's look at solutions here. So the first question is question number 1A. We are talking of finding the 80th term, but let us write the sequence first. We have the sequence 4, 2, 1, da. So for me to find the 80th term, I need to use this formula which is here. Hence, for you to use the formula, you need to know what the first term is, and you need to know the common ratio. When you know the common ratio and the first term, then you can go ahead and find any term of your choice. So let us just write a data here, as I always write data here, to help us. Let us write the formula as well. So we are saying that the 80th term is the one we want, but let us write the formula first, n minus 1. Now let's see if we have this thing. A, do we have our A? Do we have our common ratio? And do we have do we have our n? Okay, the nth term. First term in this one, we have our first term to be 4. This is my second term and this is my third term. So this first term, it is 4. I have 4. Then what is my ratio? I don't know. What about the nth term? The nth term is the one they're asking to say the 80th term. So we have 8 here. So we just write 8 there. So the only thing we need to find is the common ratio. Then we can use the formula. So let us find the common ratio. How do we find the common ratio? Remember, the common ratio of a geometric progression is not the same as the common difference of arithmetic progression. So the way you work them out is totally different. So let us work out the common ratio. So how do I find the common ratio? We learned in the previous video that term 2 divided by term 1. That's how I find my common ratio. So in this scenario, we are simply saying the common ratio for this one, it will be 2 divide by 4. So what will be my answer? 1 over 2. So 1 over 2, it is the common ratio. So we can replace it here now to say 1 over 2, it is the common ratio. Now that this is complete, you can go ahead now and find the 80th term. So we're going to say the 80th term is the one we're looking for. So first term is 4. What is my common ratio? Common ratio is 1 over 2 raised to power n. What is my n? It is 8 minus 1. Okay? Once you do it like this, then now you can work it out. Remember, these are simple things that you don't need to stress. So let us work it out. We want to find the 80th term. So we deal with the powers first. So we leave the 4 there and 1 over 2 there. Then this we have 9. Okay? So when you reach at this stage, remember, everything inside the brackets, which is 1 over 2, is raised to power 9. 1 is raised to power 9 and 2 is raised to power 9. There's nothing that is not raised to power 9 here. So apart from 4. So we are going to say the term 8 therefore is going to be 4, we say 1 to power 9 over, okay, let me write it nicely. I just want to show you how you can expand this one. We're going to say 1 to power 9 over 2 to power 9. It means that I've gotten rid of this power, I've distributed it equally, the way it's supposed to be. Then you can start doing your working and say, 4, you leave it there. 1 to power 9, the answer still remains to be 1. What about 2 to power 9? You see why I said that you need a calculator now? Yes, because without a calculator, imagine you say 2 times 2 times 2 times 2 times 2, 9 times, you're wasting time. So the easiest way now is to use your calculator. You just punch it and say, what is 2 to power 9? You have, okay, 2 to power 9, we are going to have, no, it's not supposed to be 9. It's supposed to be 7, not 9. Should remind me first. Okay, because 8 minus 1 is 7. So this is supposed to be 7, and this is supposed to be 7, and this is supposed to be 7 there. Good. Like that, we are correct. So, 1 to power 7, we know is 1. Now, but 2 to power 7, we have 128. So, 128 is our answer there. Therefore, now we can multiply this by simply saying 4 times 1, we have 4 divided by 128. Therefore, our final answer will be, how many times can 4 go into 128 divided by 4? It is 32. So we have 1 over 32. So the 80th term they are asking us about, it is 1 over 32. So this is our 80th term. That's how we find the 80th term. Okay? The 80th term is 1 over 32. Now, you can see that this answer is true because the sequence, it is reducing. It started with 4, but it's going 2, 1 to decimals until you now are going to the smallest number, which is 1 over 32. You can leave your answer as a fraction, or you can leave it in a decimals because you have a calculator, so it should be easy for you to work it out. So they will tell you that leave your answer in decimals, in 2 decimal places, or in 3 significant figures. That way, it means that you are supposed to say 1 divided by what is 1 over 32, which we have decimals 0.0312. So I'll prefer you leave your answer there and you are done. That is how you write the 80th term. So any term they will ask you, be it 20th term, as long as you know the common ratio, you can still find the 20th term, you can still find the 30th term, you can still find the 100th term, as long as you know the formula and the common ratio, the first term, you know it. You can easily work it out. Now let us see how we can find now the expression, which is the formula. Okay, so I'll erase this part. So we work our B there. So we are going to find the B. B, they are simply asking us to find the nth what? Term. Okay? We want to find the nth term. This is the formula. Okay? The formula for the nth term. So how do I find the expression for the nth term? I need to write the formula. Okay? The formula, it is simply T nth term is equal to A R n minus 1. Hence, I do the same. I don't know the nth term. So n, I don't know what n is. So they want me to write an expression, but I know my first term and my common ratio. So that should be easy for me to work out. So I don't know my nth term, but I know my first term to be 4, and my common ratio, I know it to be 1 over 2 raised to power n minus 1. I've replaced there. So I need to work out now I need to work out this so that it can be an expression, a formula. Okay, so how do I work it? Now here we shall use indices. Okay, so if you forgot your indices, I would prefer you go back and watch previous videos on indices, and you shall be able to understand what we are doing here better. Okay, so let us work out this one. How are we going to work it out? We are simply saying that the nth term is equal to, okay? Now, if we can look at this question very well, you will see that there is a 2, 4, we can raise it to a certain number for us to get 4. What number is that one? It's 2. So we're going to say 2 raised to power 2, then therefore, open brackets. Look at this. The expression 1 over 2, before they wrote it in this manner as a fraction, it was in the form of 2 to power negative 1. 2 to power negative 1 is the same as 1 over negative 2, according to indices. So it means that we need to transform this one, take it back to this way, then we can multiply the powers by using the indices law. So we are simply saying 2 to power negative 1, n minus 1. Have you seen that part? That is, we have used this in this law. Therefore, now we can multiply this part. Okay? So we are going to say, okay, let me erase this part. So we are going to say 2 to power 2, and then open brackets, 2 raised to power negative 1 multiplied by negative n, it is negative n. Negative 1 multiplied by negative 1, it is positive what? 1. I've done the needful like that. So once you do it like this, therefore now you come to know, there is another law of indices which is saying this is same as multiplication. When you have two bases, when the bases are the same, what do you do with the powers? You add the powers. Look at this, the bases are the same. So what do? You add the powers. Remember, this is we are trying to find the expression. So we are simply saying that Tn now is going to be, we maintain the base which is 2 and add the powers. So it will be 2 plus n negative n plus 1. That is how it's going to be like. Okay? Negative n plus 1. Let me not put the brackets there, but let me just put it here so that we'll see the difference, because negative and positive, they are multiplying. So now we come to this situation. When we reach at this situation now, we are going to say Tn, okay, look at the way it is now here. Okay, we say we have come to this situation where 2 to the power 2 plus this part we are saying is equal to, now we have 2, okay, we write the base, then 2 plus 1, it is 3. So 2 plus 1, we have 3. Positive term is negative. Positive times negative is negative n. Negative n. Therefore now, the expression they are asking about, the expression, okay, the expression is Tn is equal to 2 to power, you can write it 3 minus n, or you can say n minus, so we just write it 3 minus n. This is the expression they're asking about. Or we can say this is the formula they're asking about. So when you use any term now, say let me find the 20th term in this sequence. You can use this formula to find the 20th term. Or the 80th term, you can use this formula. Just replace here 3 minus 8. What is 3 minus, we say 3 minus 8, we have 3 minus 8. So we are going to say it is 6, 5, okay, 5, negative 5. 2 raised to power negative 5, we are going to get 1 over 32, which will of course will be the decimals. Simple, okay? Try to use your calculator and see how you find this one. Otherwise, this is how you work the geometric progression. Remember, indices that are applicable here, so use indices to find your expression very easy. If you forgot your indices, it is high time for you to go back and look at your indices and be able to answer this. By the way, geometric progression is one of those sequences which comes in a fashionable way and very tough way. So you need to watch every step that I do on geometric progression for you to be able to solve the questions that will come. We shall see how complicated questions come when we start doing the ECZ examination questions once we are done with the sum to infinity. So don't miss the next video. It will be so exciting because we shall look at geometric mean now. How to find the geometric mean. And then after that, we shall look at the sum, how to find the sum of a geometric and sum to infinity, and we shall be done. As for now, let's end here, and hopefully I've made this easy for you. Pause the video, watch it, and copy the notes so that you can easily remind yourself there and then. God bless, and see you in the next video. Bye.